infinite limit and limit at infinity. At the end of the lesson, students should be able to 7.1f find infinite limit, limit fx when x approaches a equal to positive infinity, or limit fx x approaches a equal to negative infinity. And if the answer is positive infinity and negative infinity when x approaches a, we said that limit are undefined. 7.1g, find limit at infinity. Limit fx when x approaches infinity equal to L, and limit fx when x approaches negative infinity equal to M. Okay, infinite limit. Consider the graph of fx equal to 1 over x squared. As x approaches 0, when x approaches 0, x squared also approaches 0, and 1 over x squared become very large. Okay, when we substitute x equal to 1 in fx, we get fx equal to plus minus 1, and you can show in the graph plus minus 1 is here. When x equal to 0.5, fx equal to plus minus 4. In the graph we can see plus minus 4. 0.1 plus minus 100. When x equal to 0.01, fx equal to plus minus 10,000. And when we substitute 0.001, fx equal to 1 million. So when we substitute value of x that very close to 0, the fx become very large. Okay, from the graph we can see that when x approaches a from the right, fx increase without bound. Then we write limit fx when x approaches a from the right equal to positive infinity. Okay, we can see that when x approaches a from the right, fx approaches infinity. Okay, number 2, when x approaches a from the left, fx increase without bound. Then we write limit fx when x approaches a from the left equal to infinity. Okay, we can see that when x approaches a from the left, fx approaches infinity, and therefore limit fx when x approaches a equal to infinity, and limit are undefined. From the graph, as x approaches a from the right, fx decrease without bound. Then we write limit fx when x approaches a from the right equal to negative infinity. Okay, we can see fx approaches negative infinity. Okay, number 2, as x approaches a from the left, fx decrease without bound. Then we write limit fx when x approaches a from the left equal to negative infinity. Okay, fx approaches negative infinity. Therefore, limit f(x) when x approaches a equal to negative infinity. So limit are undefined. Okay, from the graph we can see that when x approaches a from the right, f(x) increase without bound. Then we write limit f(x) when x approaches a from the right equal to positive infinity. Okay, we can see that when x approaches a from the right, f(x) equal to positive infinity. Number 2, when x approaches a from the left, f(x) decrease without bound. Then we write limit f(x) x approaches a from the left equal to negative infinity. Okay, f(x) approaches negative infinity. Therefore, limit f(x) x approaches a does not exist, because limit x approaches a from the right is infinity, and limit x approaches a from the left, f(x) equal to negative infinity. Limit f(x) x approaches a from the right not equal to limit f(x) when x approaches a from the left. Therefore, limit f(x) does not exist. Limit for a, limit 1 over x plus 2 when x approaches negative 2 from the right. B, limit 1 over x plus 2 when x approaches negative 2 from the left. Okay, let's see example 1. Find one-sided limit for a, limit 1 over x plus 2 when x approaches negative 2 from the right. Okay, first we substitute x equal to negative 2 in x. We get 1 over negative 2 plus 2, and negative 2 plus 2 is 0. So the answer is 1 over 0. And 1 over 0, we don't know the answer. The answer is either infinity or negative infinity. So for this question, we must substitute value that close to x. Okay, example, we choose value negative 1.99. Negative 1.99 plus 2 is positive. To know the signs of x plus 2, because actually we know the answer is infinity, but we just want to know either it is positive or negative. 1 is positive, positive divided by positive, we get positive infinity. For this question, when we look at the graph, we can see that when x approaches negative 2 from the right, the graph approaches positive infinity. Okay, for question B, limit 1 over x plus 2 when x approaches negative 2 from the left. Also, we substitute negative 2 in x, we get 1 over 0, and the answer is infinity. So we must substitute value very close to x from the left. We substitute negative 2.11 in this limit. So negative 2.11 plus 2, answer is negative. 1 is positive. Positive divided by negative is negative infinity. Okay. From the graph, we can see that when x approaches negative 2 from the left, fx approaches negative infinity. Okay, example 2. Find limit if exists. Question A. Limit 1 over x minus 1 when x approaches 1. Okay, we do the same things. We put 1 in this limit, so we get the answer is 1 over 0, and 1 over 0 is either infinity or negative infinity. So we must find limit from the right and from the left. Okay, look at the limit from the right. So limit 1 over x minus 1 when x approaches 1 from the right, we substitute value that very close to 1 but from the right. So we put 1.1 in x, so 1.1 minus 1 is positive. 1 is positive. Positive divided by positive is positive infinity. And then we look at limit 1 over x minus 1 when x approaches 1 from the left. We substitute 0.9, so 0.9 minus 1 we get negative as a answer, and 1 is positive. Positive divided by negative, we get negative infinity as a answer. Okay, look at limit x approaches 1 from the right. We get the answer is positive infinity, and limit x approaches 1 from the left, the answer is negative infinity. So limit x approaches 1 from the right not equal to limit approaches 1 from the left. Therefore limit x approaches 1 over x minus 1 does not exist. Okay, for question B, limit 1 over 2 times x minus 2 squared when x approaches 2. Okay, we put 2 in this limit, so we get 2 minus 2 is 0. 0 squared is 0. 2 times 0 is 0. So the answer is 1 over 0, and we know that the answer is either infinity or negative infinity. So we must look at limit. Okay, we find limit 1 over 2 times x minus 2 squared when x approaches 2 from the right. We substitute value very close to 2. Okay, for limit 1 over 2 x minus 2 squared when x approaches 2 from the right, we substitute 2.1 in this. We get 2.1 minus 2 is 0.1. 0.1 is positive. Positive squared, we get positive as an answer, and positive times 2 is positive. So for denominator, the answer is positive, and 1 is positive, so the answer is positive infinity. Okay, for limit 1 over 2x minus 2 squared. When x approaches 2 from the left, we substitute value that very close to 2, such as 1.9. 1.9 minus 2 is negative 0.1. Negative 0.1 squared, we got positive. Positive times 2 is positive, so denominator is positive and numerator is positive. Positive divided by positive, the answer is positive. Okay, limit x approaches 2 from the right equal to limit x approaches 2 from the left. So limit x approaches 2 is positive infinity. But we know that if the answer is positive infinity when x approaches a, we call that limit are undefined. Okay, limit at infinity number 1. Okay, look at the graph. When x approaches infinity, fx approaches L. So we can write in limit fx when x approaches infinity equal to L. Okay. For the second graph, when x approaches negative infinity, fx approaches L. So we can write limit fx when x approaches infinity equal to L. L is limit at infinity. Okay, number 2. When limit fx when x approaches infinity, the answer is positive or negative infinity, or limit fx when x approaches negative infinity, the answer is positive or negative infinity. We said that limit does not exist. Okay, limit at infinity for limit fx plus minus gx, x approaches positive infinity. Okay, look at example 3. Find the limit a, limit e to the power of x plus 2 when x approaches infinity. B, limit z 1 plus x squared when x approaches negative infinity. And C, limit 2 minus x when x approaches positive infinity. For question A, limit e to the power of x plus 2 when x approaches infinity. So we substitute infinity in x, so we get e to the power of infinity plus 2, and we know e to the power of infinity is infinity, and infinity plus 2, we get the answer is infinity. Okay, for question B, limit square root of 1 plus x squared when x approaches negative infinity. We substitute negative infinity in x, we get square root of 1 plus negative infinity squared, and negative infinity squared is infinity. So 1 plus infinity is infinity, and square root of infinity are infinity. Okay, C, limit 2 minus x when x approaches positive infinity. We substitute infinity in x, we get 2 minus infinity, and minus, the answer is negative infinity. So we said that limit does not exist. Okay, you can do this exercise in your books and answer this extra exercise. Find the limit if exists. For A, limit x plus 4 over x minus 2 when x approaches 2. B, limit x plus 5 over x minus 2 times x plus 1 when x approaches 2. C, limit 3x minus 1 when x approaches infinity. D, limit square root of x minus 3 when x approaches infinity. And limit at infinity. Learning outcome for this lecture. At the end of this lesson, students should be able to determine limit fx over gx when x approaches infinity, when limit fx x approaches infinity and limit gx x approaches infinity are undefined. Use the theorem for n greater than 0. Limit x approaches infinity 1 over x to the power of n equal to 0, and limit x approaches negative infinity x to the power of n equal to 0. Okay, let's see limit at infinity of the rational function. Okay, we look at for n greater than 0, limit x approaches infinity 1 over x to the power of n equal to 0, and limit x approaches negative infinity 1 over x to the power of n equal to 0. Example 4. Find limit x approaches infinity fx and limit x approaches negative infinity fx. A, fx equal to 1 over x squared, and B, fx equal to 3 over x squared minus 5 over x cubed. Okay, for question A, fx equal to 1 over x squared. Okay, we find limit x approaches positive infinity 1 over x squared. We know we must substitute infinity in x. We get 1 over infinity squared, and infinity squared is infinity. Okay, 1 over infinity, we know the answer is 0. Okay, look at limit x approaches negative infinity 1 over x squared. Okay, we substitute a negative infinity in x. We get 1 over negative infinity squared. Negative infinity squared is infinity, and 1 over infinity, the answer is 0. Okay, for question B, fx equal to 3 over x squared minus 5 over x cubed. Okay, let's see limit x approaches positive infinity 3 over x squared minus 5 over x cubed. Okay, substitute infinity, we get 3 over infinity squared minus 5 over infinity cubes, and we simplify, we get 3 over infinity minus 5 over infinity. 3 over infinity is 0, and 5 over infinity is 0. 0 minus 0, the answer is 0. Okay, limit x approaches negative infinity 3 over x squared minus 5 over x cubed. We substitute negative infinity in the question. 3 over negative infinity squared minus 5 over negative infinity cubed, and negative infinity squared, we get the answer is infinity, and negative infinity cube, we get the answer is negative infinity, and we simplify, we get 3 over infinity plus 5 over infinity. So the answer is 0. If limit x approaches infinity, fx over gx equal to infinity over infinity, then we will to divide the numerator and denominator by the highest power of x of denominator. And infinity over infinity, we don't know the answer, or we can say that infinity over infinity is indeterminate form. Example 5. Find a limit x squared plus 1 over 2x squared plus 1 when x approaches infinity, and b limit x squared over 3x minus 1 when x approaches negative infinity. For question A, limit x squared plus 1 over 2x squared plus 1 when x approaches infinity. When we substitute infinity in numerator, we get infinity squared plus 1, and the answer is infinity. For denominator, also we substitute infinity in x squared. 2 times infinity squared plus 1, the answer is infinity. So we must divide the function with highest power of denominator. For this question, we look at denominator, and we can see that x squared is the highest power of denominator, so we must divide all terms in this limit with x squared. X squared divided by x squared, and 1 also divided by x squared. 2x squared divided by x squared plus 1 divided by x squared. X squared divided by x squared, we get 1 plus 1 over x squared is 1 over x squared. 2x squared divided by x squared, we get 2, and 1 over x squared is 1 over x squared. And when we substitute infinity in this limit, we get 1 plus 0 over 2 plus 0. So the answer is 1 over 2. Okay, for B, limit x approaches negative infinity, x squared over 3x minus 1. And let's see the denominator for this function. Denominator is 3x minus 1, and we know x is the highest power of denominator. Okay, we divide this term with x, so x squared divided by x squared over 3x divided by x minus 1 divided by x. X squared divided by x, we get x as an answer, and 3x divided by x, we get 3, and minus 1 over x. And when we substitute negative infinity in x, we get that negative infinity over 3 minus 1 over negative infinity, and we simplify, we get negative infinity over 3 plus 0, and negative infinity divided by 3, we get the answer is negative infinity. That we know that when limit x approaches negative infinity, the answer is negative infinity. So we said that limit does not exist. For square root of a rational function, we divide each term by x, because modulus x equal to positive x when x greater than or equal to 0, negative x, x less than 0. Okay, modulus x equal to square root of x squared and equal to plus x when x greater than or equal to 0 and negative x when x less than 0. Example 6, find limit x approaches positive infinity x plus 1 over set x squared plus 1 and limit x approaches negative infinity set x squared plus 2 over 3x minus 6. For question A, limit x approaches infinity x plus 1 over set x squared plus 1. When we substitute infinity in x, we get infinity plus 1, we get infinity, and set infinity squared plus 1, also we get infinity. So the answer is infinity over infinity. So we must divide with the highest power of denominator. We can see that denominator is set function and x squared is the highest power of the denominator, so we need to divide it with set function. Also, we need to divide with set x squared for the denominator. Meanwhile, for the numerator, we can just simplify, divide by x, because when x approaches infinity, set x squared equal to x. X divided by x and 1 also divided by x. One plus 1 over x over set x squared over x squared plus 1 over x squared. So we get 1 plus 1 over x over set 1 plus 1 over x squared. And when we substitute infinity in this limit, so we get 1 plus 0 and set 1 plus 0, and we can get 1 over set 1. Set 1 is 1, so the answer is 1. For question B, limit x approaches negative infinity, set x squared plus 2 over 3x minus 6, and we know that x is the highest power of denominator, so we must divide the denominator by negative x. Why negative x? Okay, from set x squared, we know set x squared equal to modulus x equal to plus minus x and minus x. When x approaches negative infinity, we know that the function is negative x, so we must divide the denominator with 3x divided by negative x and negative 6 divided by negative x. For numerator, we can divide by set x squared. And when we simplify, we get set 1 plus 2 over x over negative 3 plus 6x. Okay, when we substitute negative infinity in this limit, we get z1 plus 0 over negative 3 plus 0, and we will get z1 over negative 3 and z1 equal to 1. So the answer is 1 over negative 3, or we can write negative 1 over 3. For the function, if limit fx minus gx when x approaches infinity equal to infinity minus infinity, we call this is a indeterminate form. So we must multiply by the conjugate and to divide the numerator and denominator by the highest power of x of the denominator. Example 7, find limit x approaches infinity, square root of 4x squared plus x minus 2x. Okay, for this question, limit x approaches infinity, set 4x squared plus x minus 2x. When we substitute infinity in x, we get set for infinity squared plus infinity. So the answer is infinity minus 2 times infinity is negative infinity. Infinity minus infinity, we don't know the answer, so we must multiply this question with conjugate. Okay, conjugate for set for x squared plus x minus 2x is set for x squared plus x plus 2x. Then we simplify this question. We know a plus b times a minus b. The answer is a squared minus b squared. So we use to simplify this question. We can simplify this question. Set for x squared plus x minus 2x times set for x squared plus x plus 2x. So we get limit x approaches infinity, set for x squared plus x squared minus 2x squared squared, and the denominator is still the same, set for x squared plus x plus 2x. And we solve this question. We get set for x squared plus x squared. The answer is 4x squared plus x minus 2x squared squared. The answer is 4x squared. And denominator is still the same. And we simplify this question. 4x squared plus x minus 4x. So 4x squared minus 4x squared is 0. So the answer is limit x approaches infinity, x over set 4x squared plus x plus 2x. And when we substitute infinity in this limit, we get infinity for the numerator and infinity for denominator. So when the answer is infinity over infinity, we must divide this limit with the highest power of denominator, and the highest power of denominator is x squared, but x squared is in the third form, so we must consider what we're going to divide. In third form, we must divide with x squared, and out the third form we must divide by x because x approaches positive infinity. So we must divide x with x, set for x squared over x squared plus x over x squared, and plus 2x we divide by x. Okay, so the answer is x over x we get 1, set for x squared over x squared we get set 4 plus 1 over x and plus 2, and we substitute infinity in this function, so we get 1 over set 4 plus 0 plus 2, and set 4 or square root of 4 is 2, and when we simplify this question we get 1 over 2 plus 2, and we get 1 over 4. Okay, you can answer this question as your homework.